You ever stop and wonder about the little mysteries all around us? Well, today we're going to uncork the science behind a really delicious one.
All right, let's just dive right in. I want you to picture this. Someone's in the kitchen cooking something absolutely amazing. You're way over on the other side of the room, but that mouth-watering smell, it just floats right over to you. How in the world does that happen? But now, let's flip that. Think about some cold food, maybe leftovers, straight out of the fridge. To get a sniff of that, you have to get right up close, don't you? You almost have to stick your nose in it. It's the same basic food, just cold. So what gives? Well, the answer, as it turns out, is all about the very nature of, well, stuff. The nature of matter itself. So let's dive into the scent of science. So this all starts with a huge concept called matter. And honestly, it's simpler than it sounds. That sizzling food, that's matter. The air between you and that food, also matter. You? Yep, you're matter too. Basically, from a tiny grain of sand all the way up to a giant star, if it has mass and takes up space, scientists just call it matter. You know, for the longest time, people argued about this. Is matter just one solid, continuous thing? Or is it made up of teeny tiny little pieces? Well, science has given us a really clear answer, and this is our first huge clue. Everything is made of unbelievably small particles. So how can we be so sure? Well, check out this classic experiment. It's pretty cool. You take just a few little crystals of this stuff and dissolve them in water. Then you take just a little bit of that colored water and add it to more clear water. And you do it again and again. And you know what? After diluting it like 5, 6, 7 times, the water is still colored. The only way that's possible is if those original few crystals were made of millions and millions of tiny particles all spreading out. So when we say tiny, how tiny are we talking? We're talking small, beyond our imagination. Seriously, it's kind of mind-blowing when you think about it, right? Everything around us is built from these impossibly small building blocks. Okay, so we've established that everything's made of particles. Got it. But to actually solve our mystery about the food smell, we gotta know how these particles act. And it turns out they pretty much follow 3 simple rules. All right, here they are, the 3 big rules for particles. Number 1, there's actually space between them. Number 2, they are always moving, all the time. And number 3, they kind of stick to each other. They have a force of attraction. Let's break each of those down. So, rule number 1, space between particles. How do we know that? Well, think about this. You take a glass of water, you mark the level. Then you dump in some salt and stir it up until it disappears. Now, you'd expect the water level to rise, right? But it doesn't. Why? Because those little salt particles are just fitting right into the empty gaps between the water particles. Isn't that wild? Okay, on to the second rule, that constant movement. Now this is a huge piece of our puzzle. Particles are always, and I mean always, jiggling around. They have this thing called kinetic energy. And here is the absolute key to everything. The hotter you make something, the faster its particles move. More heat means more movement, more kinetic energy. You gotta remember that link. Heat equals speed. And finally, rule number 3, attraction. The best way to picture this is to think of particles like a big group of dancers, and they're all holding onto each other, locking arms. That's the force of attraction. Now, sometimes that grip is really, really strong, and other times it's pretty loose, but there's always some kind of force holding them together. So, you've got these 3 rules, right? The spaces, the constant movement, and the attraction. And these aren't just some random science facts. The way these 3 things balance each other out is what determines what form something takes. And that leads us straight to the 3 states of matter we all know. This table really pulls it all together. Look at a solid. The attraction between particles is super strong. That's our dancers holding on for dear life. They can't go anywhere. They can just kind of vibrate in place. Now in a liquid, that attraction is a little weaker. The dancers can slide past each other now. And in a gas, well, the attraction is almost nothing. The dancers have let go completely and are just flying around the room at high speed. That's why a gas will always fill up whatever container you put it in. All right, let's recap. We've got all our clues laid out. We know that everything is made of particles. We know those particles are always moving. They stick together, and there are gaps between them. It's time to put on our detective hats and finally crack this case. So, let's go all the way back to the beginning. That hot, sizzling food. What is actually happening on a particle level? Okay, step 1. Heat. When you cook the food, its temperature goes up. And what did we just learn? More heat means more kinetic energy. So the particles in that food start jiggling and vibrating like crazy, way, way faster. They start moving so fast, so violently, that they build up enough energy to break free from the forces holding them together. They literally break that dancer's grip that we were talking about. And once they break free, these super high energy particles just launch themselves off the surface of the food, right into the air. They have just changed their state. They went from being a part of the solid or liquid food to being a gas. So now you have all these little smell particles floating around in the air as a gas. And remember, gas particles move really fast and there's tons of space between them. So they just naturally mix in with all the air particles in the room. This mixing process has a name. It's called diffusion. And that is how the smell gets all the way from the pan across the room and right to your nose. And this is the aha moment, because it perfectly explains the cold food. With cold food, the particles have really low kinetic energy. They're moving super slow. Hardly any of them have enough juice to break free and escape as a gas. So if there are no escaping particles, there's no gas, there's no diffusion, and there's no smell reaching you from across the room. Boom, mystery solved. And once you get this, you start seeing it everywhere. Like, think about when you sweat on a hot day. The water particles in your sweat that have the most energy, the fastest ones, are the first to escape, to evaporate. But to do that, they have to take some heat energy away from your skin. That's why sweating cools you down. It's the exact same science, just in a different situation. So, there you have it. By understanding how these tiny, invisible particles work, we can explain so much about the world we see every day. We've talked about solids, liquids, and gases, but it kind of makes you wonder, doesn't it? What happens at the real extremes, like super high temperatures inside a star, or the insane cold near absolute zero? Could there be other, even weirder states of matter out there? That's something to think about.